Hello everyone. Okay, so the last program in chapter 7 is Lo Shu Magic Square. Okay, so the Lo Shu Magic Square is a grid with 3 rows and 3 columns, shown in figure 7-8. The Lo Shu Magic Square has the following properties. The grid contains the numbers 1 through 9 exactly. The sum of each row, each column, and each diagonal all add up to the same number. This is shown in figure 7-9, so that's the figure here. So basically, if it's a Lo Shu Magic Square, then if you add up all rows, if you add up all columns, they should all sum up to the same number. So 4 plus 9 plus 2, I hope I didn't change these numbers, but 4 plus 9 plus 2 gives us 15. And then if you add all the rows, it should also give you 15. 3 plus 5 plus 7, 8 plus 1 plus 6 should give you 15. At the same time, if you add up the columns, which is 4 plus 3 plus 8, it should give you 15. 9, 5, 1 should give you 15. 2, 7, 6 should give you 15. Also, if you add up the diagonals, so if you start from here, 4, 5, and 6, that should also give you 15. And then the other diagonal, 2, 5, and 8, that should also give you 15. All right, so it says, in a program, you can simulate a magic square using a two-dimensional list. Write a function, a function that accepts a two-dimensional list as an argument and determines whether the list is a Lo Shu Magic Square. Test the function in a program. Okay, so let's start. Let's start with the main function. Okay, so I'm going to define the main function. Okay, and let's go ahead and declare a two-dimensional list, or like create and initialize a two-dimensional list. So I'm going to call this user two-dimensional list. So user two-dimensional list, and that's going to be initialized to a list. All right, so a two-dimensional list is basically a list that contains other lists. So this is one list, but in this list is going to contain other lists. If you want, I'm going to keep it on one line, and then later on I'll separate it. So this is one list, and in this is going to contain one list. So this is the first list, okay, in this two-dimensional list. So 492 is going to be another list. So as another list, I'm going to create 492. And then I'm going to separate each item in this outer list with a comma. All right, it's an outer list with several lists in this first list. I'm going to separate it with a comma. The next item with a comma. And then the other next item is going to be 3, 5, 7. That's another list. So 3, 5, 7. It then separates that also with a comma. And then the last list is going to be 8, 1, 6. So 8, 1, 6. Okay, so we have a list. Okay, a list with 3 lists in there. That's a two-dimensional list. And I like to break it down so it's logical. I like to break it down this way so it's logical. So we have a list that contains 3 lists. So that's our two-dimensional list. I'm going to call it user two-dimensional list. Now, the question said a Lo Shu Magic Square is a grid with 3 rows and 3 columns. So we can go ahead and assume that the two-dimensional list is always going to be a 3 by 3, a 3-row and 3-column list. But the program also over here said we should create a function that accepts a two-dimensional list. Now, if we write a program that it's hard-coded in it, that the list has 3 rows and 3 columns, if we pass in a list that contains 5 rows and 5 columns, then it wouldn't work. So let's make this program dynamic and flexible. Let's create this program in such a way that when you pass in any list, whether it's a 5 by 5 list or a 10 by 10 list, it will automatically know the number of rows and number of columns. It will know that it's a 10-row and 10-column list and so on and so forth. Let's not just stick with 3 by 3. So I want us to create a function that's going to take this two-dimensional list and tell us how many rows and how many columns this two-dimensional list is made of. Well, first of all, this Lo Shu, it has to be a square. So you can't have, let's say a row with two elements in here, a row with 5 elements, and it has to be a perfect square. So let's create a function that's going to take this two-dimensional list and tell us how many rows and columns there are in this list. So I'm going to define a function, and I'm going to call it get rows and columns. All right, so now we have to determine if this function is going to accept in any argument. Well, if we're going to get the rows and columns, we're going to get the rows and columns of something, and that something happens to be our list. So in order for this function to get or return the rows and columns, you need to give it the function that you need to give it the list that it should tell you the rows and columns are off. So I'm going to define a parameter, and that parameter is going to be a placeholder for our two-dimensional list. I'm going to call it user two-dimensional list. Basically, I'm going to call it the same name as this. It doesn't matter if you're giving it the same name as this. They are considered two different lists or two different names because they are in two separate functions. The scope of this name here is within this get rows and columns function, and then the scope of this name or this list is within the main function. So it doesn't matter if you use the same names. They don't see each other. Sorry, I still have that, that strange cough. All right, so let's first start with the rows. So in order to get the rows of this list, in order to get the rows of this list, that's the length of this list. If you get the length of this two-dimensional list here, it's basically how many elements are in this list, how many individual elements, how many rows in this case, how many rows are in this element. So there are 1, 2, and 3 rows in this list. So if you get the length of the list itself, that's how many rows there are. And so if you call the len function, which is the length function, len function, and you pass in the two-dimensional list that was given to this function, it's going to return the number. It's going to basically return the number of rows or number of elements in this list itself, which basically represents our number of rows. So I'm going to create a function. When it's returning that value, we need a place to store it. So I'm going to create a variable. I'm going to call it number of rows. So number of rows is going to be the length of the list itself. Okay, so now how do we know the number of columns in this list, right? So this two-dimensional list has three. In this case, it has 3 columns, right? This is the first column. This is the second column. This is the third column. But how do we get that number? Well, we can get the length of any of the rows, right? We can get the length of any of these rows. That's how many columns? Because since they're all the same, they all have the same number of columns, we can just access this row, this element here, and get the length of it, and it will tell us it's 3. There are 3 items in this list. It doesn't matter which one. I'm just going to stick with the first one. To access the first row in this list, okay, you can refer to the name of the list and the index of this row. This has index 0. And so in order to access this row, you use index 0. In order to access this row, you use index 1. You use index 2 for this row. Doesn't matter. Let's just use the first row. So I'm going to get the length of this element here, of this row here. And I need to refer to the name of the list itself and use square bracket to target or specify what index. Okay, so in this case, this is index 0. I want to get the length of this row here. All right, and it's going to return that number, and that number is going to represent our number of columns. So when it's returning that number, we need a place to store it. I'm going to create a variable called number of columns. Number of columns to store that value. So now we have our number of rows, number of columns. Now in Python, you can return multiple values. And so I'm going to return our number of rows, and I'm going to separate the next value that I want to return. I'm going to basically separate these values with commas. So the next value I want to return is our number of columns. So in Python, you can send multiple values this way. When you are receiving it, okay, when you call this function anywhere else, you should know that it's returning 2 values. And so you should also have 2 variables to receive these 2 values, and you have to receive them respectively. This is the first one that comes out first, or this is this is the value that comes out first. And so the variable that you're using to receive this value, like the first variable, okay, that you're using to receive this value is going to accept this value here, and the second variable you're using to receive the next value is going to accept this value. Don't worry, you'll see it in action. But it's returning these 2 values, and it's returning them respectively. This one first and then this one next. So we're done with this function. It gets our rows and columns for us. All right, so the next function I want us to create is the first row sum, right? Just get basically look at the first row and tell us the sum of all the numbers in there. The reason why I want us to do that is because we need a starting point. So if we get the sum of this, and it's, let's say 15, right? In order for this square or this two-dimensional list to be a Lo Shu Magic Square, then the next row sum has to be the same as 15. If we check this and it's 15 and we add this up, it has to be 15. If we add this up, it has to be 15. If at any point we realize that while we are checking the sums, it's not 15, then we know it's not a Lo Shu Magic Square. So let's just have a starting point. Let's get this starting point, and we'll use that to compare every row. Okay. All right. So let's just get this value first. So I'm going to create a function, and I'm going to call it get first row sum. You can also do first column sum. It doesn't matter. If you get the first column sum and you compare the sums and you realize that at any point, any sum doesn't match to that sum, then you know that two-dimensional list is not a Lo Shu Magic Square. So let's get the first row sum, and we'll find out if this function get first row sum. We will find out if this function is going to accept any argument, so we can define it. So let's go ahead and do it. So basically what we want to do is, like I said, get the sum of this first row. And how do we do that? That means we're going to loop through this particular row here, and in order to access this value, it's it's the item with index 0 in this list, right? We know that, and so we have to target this row and then loop through the elements in there. So let's see. Since we're just going to go through the first row, then we need a number of columns so we can know how many times we are going to loop through that row, right? Also, I'm trying to figure out if we need a list. So we need a list itself, of course, right? Because if we are going to go through the numbers, then we need a list itself. So let's first define that as a parameter. The list itself, I'm going to call it the same as use a two-dimensional list. And then we need how many columns, right? Now you can access it from this list, but since we've created a function that is going to get us the number of rows and number of columns, once we call the get rows and columns and it returns the number of columns, we can use it. We don't have to keep writing loops to go through it again. We have the number of columns. We don't have to write code to get it again. So we have the number of columns. We can just I'm defining a parameter for it, right? We will have that number always ready for us to pass to this function, right? And so I want to loop through just the first row in this two-dimensional list. It has index 0. So I'm going to create a loop to first target this, or to loop through this. So I'm going to create a for loop. Okay, so I'm going to create a target variable, and that target variable is going to represent the row index. So let's call it for current row index. And I'll explain this in a second. So for current row index in range, and I'm going to create a range of 1. And I'll specify that, and I'll talk about that in a second. So I want, basically, since I am targeting this row, it has index 0. So I want a number to use to target this, row here. So if I type in something like, for current row index in range 6, it's going to create, this is going to create a range create a list or a range from 0 all the way to 5. Now 6 is like the ending limit. It's not included in the range. It marks the end, of the range. It's not included. So this is going to create a range from 0 all the way to 5. And what is going to happen is, as this loop is iterating, it's going to assign these numbers from 0 all the way to 5 to this current row index variable, right? So that's what happens. So the first time this loop iterates, it's going to assign 0 to current row index. The second time it iterates, it's going to assign 1 to it, and so on and so forth. But because I'm only interested in this row with index 0, just to target this row with index 0, I'm going to type in 1. What is going to happen is it's going to create a range from 0 to 0. That's it, right? This is like the ending limit. It's not included in the range. So if it starts from 0, then it's going to create a range from 0 to 0, or basically it's going to create a range of 0. That's it. And what is going to happen is that number 0 is going to be assigned to current row index. At any time we know that current row index is going to be 0. That's it, right? And we can use that 0 to target this element or this row here with index 0 in this list. So that's our first loop. Now once we get that in this for loop, we're going to create another for loop that is going to loop through the individual elements. So this 0 here is going to target the row, right? And then we need to loop through the individual elements. So I'm going to create another loop, and I'm going to call it current for current column index in range, and I'll explain that also in a second. Now we can provide a number of columns. So number of columns according to this program so far is 3, right? So let's say I type in 3 here. So the range function over here, when I type in 3, is going to create a range from 0 all the way to 2. Okay, the numbers 0, 1, and 2. And what's going to happen is these numbers 0, 1, and 2 are going to be assigned to current column index. As this loop is iterating, the very first time 0 is going to be assigned to current column index. The second time 1 is going to be assigned to current column index. The next time 2 is going to be assigned to current column index, and that's it. 3 is like the ending limit. It's not included in the range. Okay, this is going to create a range from 0 to 2. So we start from the outer loop. We'll have current row index of 0. We know this outer loop is going to iterate only one time, right? Because this creates a range from 0 to 0, basically one number, 0. So this will be 0, and then the very first time this inner loop iterate, current column index is going to be 0. So we're going to have 0, 0. And then 0, 0 is going to be, we're going to use the 0, 0 to access the row and column. So row 0, column 0 is targeting the number 4. The second time this loop iterate, it's going to be 1. Now for the inner loop has to finish iterating first before we go back to the outer loop. The outer loop, first of all, is only iterating one time. The inner loop is going to iterate 0, 1, 2, basically 3 times, right? It's going to iterate 3 times, but then the numbers 0, 1, and 2 are going to be assigned to current column index each time it iterates. First time the inner loop iterates, its value will be 0. So we'll have row 0, column 0. That's this value here. Second time the inner loop iterates, we'll have 1. So we'll have row index 0, column index 1. Row index 0, column index 1. The third time it iterates will be assigned, current column index will be assigned the number 2. We'll have row index 0, column index 2. Row index 0, column index 2 is this value. We are just creating a mechanism or some kind of system to go through this row and all the elements in there, right? But the only difference is now I'm not going to type in 3 here. I'm going to type in a number of columns, right? Because it has to be dynamic. In this program, the number of columns is 3. But once we change the list and it has, let's say, 4 rows and 4 columns, it will still work. So instead of passing it through, let's just pass the number of columns because it's the same thing, right? I just wanted to explain to you how it works. Okay, so this loop is going to basically target this row and go through all these individual elements. But each time, what we want to do is take the element and start accumulating it up, adding it up. And so when we are adding it up, we want to get our first row sum, right? So I'm going to, before this loop, create a variable. I'm going to call it first row sum. And I'm going to set it equal to 0 because if we haven't started counting, then we have 0. And so while we are looping through this row and all the elements in there, first row sum is going to be equal to what's already stored in first row sum, okay, plus the current element we are on. We're going to use these two indices to access the current element we are on. In order to access the current element, we need to target the 2-dimensional list. So I'm going to point to the user 2-dimensional list, and I need to specify what row and what column. So the row is going to be our current row index. We know it's going to be always 0 according to the program because this creates a range of 0, just 0. So row 0, and I need to specify the column as well. The column is going to be our current column index. First time is going to be 0, next time is going to be 1, and the last time is going to be 2. So we are accessing the current value we are on as we are looping through this row. And we are adding it all up. So first row sum is going to be equal to what's already stored in first row sum plus that current value. So first time current row sum is going to be 0, right? So it's going to be 0 plus 4. And then 0 plus 4 gives you 4, right? And then 4 is going to be added to first row sum. Second time it iterates, first row sum will be 4. So we take 4 plus 9, right? And then we get 13. And 13 is going to be assigned to first row sum. When it iterates again, we're going to have 13 plus 2, right? 13 plus 2 gives us 15, and then 15 is going to be assigned to first row sum. So outside of the entire loop, outside of the outer loop, we'll have our first row sum, right? And once we have it, we can just go ahead and return it. So let's return our first row sum. Now there's a shortcut for this, the same line here. First row sum is equals to first row sum plus this value. You can write it as first row sum, okay, plus equals this value. That's just a shortcut version, right? You can read this as first row sum, okay, is increasing by this value, right? Or you can say that we are increasing first row sum by this value, right? Or something like that. Or first row sum is, yeah. So basically something like that. It's just an analogy just to help you understand it well. This is just a shortcut in case you wanted to understand it, but I'm going to take it back to how it was, the long version. First row sum is equal to first row sum plus the value. And then once we have our first row sum, let's go ahead and return it. And so now we have two functions that do these things for us. Now the next function I want us to create is to create a function that's going to return true or false based on whether this two-dimensional list has equal rows. So what we are going to do is we're going to just sum up the rows. We're going to add this up, get the sum. We're going to add this up, get the sum, right? But as we're doing that, so once we first get the sum of this, we compare with our first row sum, right? It doesn't matter. I know it's the same value as our first row sum, but the idea is to go through just the rows to get the sums of them. So we have our first row sum. We check this. 15 is equal to 15. Okay, so far it's a Lo Shu Magic Square. Then we check this next row. Is the sum equal to 15? So far it's a Lo Shu Magic Square. We check this last row. Is it 15? So far it's a Lo Shu Magic Square. But this function has equal rows will return true if it has equal row sums, right? This program this function will return false at any point if it realizes that the sum of any row is not equal to the first row sum. Because for it to be a Lo Shu Magic Square, right, the first row, the sum of any row here, all right, and the sum of all columns has to be equal to the first row sum, or it has to be equal to the first row sum, because that's just one sum of this two-dimensional list. So if there's any other sum that is not equal to that first row sum, then it's not a Lo Shu Magic Square. Sorry. So you have a better sense. Let's just go ahead and create that function. I'm going to call it has equal row sums. And don't worry, we'll create another function for has equal column sums. Don't worry about it. But let's just focus on rows. Let's just break it into pieces. And so it's easier, but it also makes sense, right? And then once we put it together, it becomes the complete project. I think it's better to code that way. Okay, so has equal row sums. We'll figure out what it needs as parameters so we can define it. So since we're going to be going through this list, then it needs a list, right? So let's define a parameter for it. I'm going to call it use a two-dimensional list as well. It doesn't matter, again, that these names are the same, right? The scope of this use a two-dimensional list, for example, is within the get rows and columns function. The scope of this is within the get row sum function, and the scope of this is within the has equal row sums function. They don't see each other at all, right? They don't see each other because they are in different functions, So it's okay to use these same names. Okay, they're all considered different because they're in different functions. So we're going to be going through this two-dimensional list. So we define a parameter for it. You need to provide a list to this function when you call it. Also, since we're going to be comparing each row sum with the first row sum, then we need to create also a place for that, right? You need to also provide the first row sum when you call this function. And then since we're going to be going through just the rows, let's see here. Again, so let's go ahead and let's go ahead. We will figure out what it needs and what it doesn't need. Actually, I got it. Since we're going to be going through the rows and columns, then we need a number of rows and columns, right? To know how many times, actually not the number of rows and columns, just the number of rows. Since we're going through just the rows, if we going through just the rows, we need how many rows there are in this list, just so we can know how many times we should loop through this list in order to access these values. So I'm going to provide another parameter. I'm going to create another parameter for that, for number of rows. So number of rows. Now I'm sure you can figure out, you can try to create another loop to go through this, or to kind of get the number of rows from it. You can, but if we've already written a function that returns the number of rows, we can call this function just once, and we can use these numbers going forward. You don't have to write loops or write code to get the numbers over and over again. We don't have to repeat ourselves. So you provide these details to the has equal row sums, and then now we create a loop that is going to go through this two-dimensional list, adding up all the rows and checking. Adding up all the rows and checking with the first row sum to see if they match, so that it can return true. If they match, it returns true. If they don't match, it returns false. So let's first start with the outer loop. So it's going to be similar to what we did over here. So for current row index in range, we need to specify how many times it should loop through it should go through, basically loop through the rows, just the individual rows itself, right? So we need to specify the number of rows over here. So if the number of rows is 3, and we know it's 3, right? 1, 2, 3. This loop is going to iterate 3 times. So we have that number to loop through the rows, but it's going to assign the numbers 0 all the way to 2. It's going to create a range from 0 all the way to 2. And what happens is each time those numbers are going to be assigned to current row index. So the first time this loop iterate, 0 is going to be assigned to current row index. The next time it iterates, 1 is going to be assigned to current row index. The next time it iterates, 2 is going to be assigned to the current row index. And that's it. 3 is not included. 3 is like the ending limit, but it's not included in the range. So if we need to specify our number of rows to this, to this loop header here. So for current row index in range, now this is just to go through our rows. Now we need to create another loop inside of this to access our individual elements here. All right, so now I realize we also need to specify our number of columns. Okay, we also need that. Just realized that. So I'm going to specify that number of columns, because we also need to know how many columns to go through it. We're not going to go through just the row. Since we're accessing each individual element, then we also need the number of columns. Okay, so that's just something I just wanted to point out there, because I was thinking just going through the rows, so we need just that. And that's the nice thing, right? As we're going forward, we figure out what we need and what we don't need, so we can specify it here. So now we need to create a loop that goes through each individual item in each row. So I'm going to create something similar to this. So for current column index in range, and now we need to specify a number of columns, right? So number of columns according to this program is 3, right? 1, 2, 3. That's the number of columns. So if I type in 3 here, this is going to create a range from 0 all the way to 2. 3 is not included in the range. 3 is like the ending limit, but it's not included in the range. So what happens is the first time this inner loop iterates, 0 is going to be assigned to current column index. The next time it iterates, 1 is going to be assigned to current column index. The next time it iterates, 2 is going to be assigned to current column index. 3 is not included in the range. So if you think about it, before that, well, the inner loop here, this inner loop is going to finish going through all its iterations before we start another iteration of the outer loop. So the very first time, current row index is going to be assigned 0. So we'll have 0 to represent the index of the row we're talking about. And then inside this loop here, we'll have 0 the first time. So row index 0, column index 0 is this value. So row index 0, column index 0 is this value, right? And then the next current row index will stay at 0, but the next value here will be 1. So row index 0, column index 1, it's still here. Row index 0, column index 1. Next time this iterates, it's going to be 2. So row index 0, column index 2. Now we've accessed these elements. Now in order to access this element, now we are done with all the iterations of this inner loop. So we come up to the next iteration of the outer loop. That's going to be 1. So row index 1, and then we start another iteration of the inner loop. So the very first time it's going to be 0. So row index 1, column index 0 is this value. And then next time it iterates, current column index is going to be 1. Row index will still, current row index will still be 1. So row index 1, column index 1, we are referring to row index 1, column index 1. That's 5. Next time it iterates, current column index will be 2. row index column, current row index will still stay at 1. So row index 1, current column index 2 will be row index here, row index 1, current column index 2, so 0, 1, 2. So by creating something like this, we are basically going through every element in the two-dimensional list. We're accessing them, and we can use them, we can do whatever we want with them. I'm not going to type in 3, I'm going to type in the number of columns, because it's the same thing. I just wanted to explain here. So what happens is we access in each element, right? And what we want to do is we want to take each element and add up the rows, get the sum of the rows, right? So the very first time this iterates, row index will be 0. Second time this iterates, current column index will be 0, 1, and 2. I mean, for all the iterations of the current column index will be 0, 1, and 2. That accesses our first row here. So let's get the sum. Let's first get the sum. We use the current row index to refer to the row, and then we use our current column index to refer to the column. And I'm going to refer to the name of the list here. All right, we want to get the sum. So before that, let's create a variable and let's call it row sum. Okay, row sum. So row sum, before we start counting, is 0. And then we're going to get the row sum. Okay, so row sum is going to be equal to what's already stored in row sum. Okay, plus, now we need to target the individual elements as this inner loop is iterating. This inner loop will iterate 3 times. It will take 4, 9, and 2 and add them all up. So row sum is equal to row sum plus row sum is equal to what's already stored in row sum plus the current value we are on, or the current values. So I'm going to refer to the name of the list and then use our current row index to represent our row we are referring to, and then use our current column index to refer to the column we are referring to. So this inner loop will iterate 3 times, right? It will add up all of this. We'll get the row sum. But before we go back up and start the next iteration and keep adding these numbers to what we already have in row sums, we need to reset it. And also we need to check to see if that number is equal to the first row sum, right? Because when this inner loop finishes iterating, that's just the sum of one row. We don't want to go to the next row and keep adding these numbers to it. Otherwise, we don't get the sum of one row, right? We just get all the elements in this loop summed up, right? We don't want that. So when this inner loop finishes iterating, we'll have the row sum. As soon as we get a row sum, outside of this inner loop, when this inner loop is done, we need to check to see if this row sum, is equal to, or basically we can start by saying not equal to. If it's not equal to, then let's get out of this function and return false. So outside of this inner loop, when this inner loop is done, I'm going to create an if statement here and say if the row sum, is not equal to. I'm using the exclamation sign and the equal sign to represent not equal to. This means not. So if it's not equal to our first row sum, after getting that row sum, if it's not equal to our first row sum, then what it means is that, this two-dimensional list doesn't have equal rows, right? Because if our first row sum is 15 and we check a row, any row, and it's not equal to 15, then it doesn't have equal row sums, and therefore it's not a Lo Shu Magic Square. So if it's not equal to first row sum, then let's go ahead and return false. This function will return false to indicate that it doesn't have equal row sums, right? All right, so this is just to test to see if that row sum we have is not equal to the first row sum. So before we go back up to the next row and add these numbers up, we already have row sum here. If we don't reset it, if we don't set it back to 0, then it will continue adding the numbers 3, 5, and 7 to row sum. So after checking, right, before we go back up, before we go back up into this loop, we can even do it outside here. Actually, we can do it here because we are done with this inner loop. Right outside of this loop, when we are done, we check the sum. We can reset it right here. We can set row sum back to 0, because what's going to happen is, it's going to go to the next row and then keep adding these numbers to row sum. If we set it to 0, row sum will be 0 here for us, and then we'll have a fresh row sum. But if we don't reset it to 0, then it will continue adding these numbers to what's already stored in row sum. We just want to check, add these rows, and compare them with the first row sum. Okay, so I hope it makes sense. So we set it to 0, and this loop will keep going. At any point, if the row sum is not equal to first row sum, it will return false. The function will just exit. It will return false. But if this loop manages to finish all of this without returning false, that means the row sum was equal to the first row sum each time, right? At some point, this loop will be done. This loop will be done, without returning false. And outside of this loop, if the code manages to get to this point, that means that all the row sums were equal to the first row sum, right? Basically, all the rows were equal. And so in that case, then let's return false. It will return false. Sorry, I said return false. Return true. In that case, let's return true. It will return true only if the code manages to get to this point, right? Because the code will return false if at any point it realizes that any row sum here is not equal to the first row sum, right? But if the code goes through all of this and doesn't return false, that means that the row sums were equal to the first row sum. And so at some point this outer loop here will exit, will be done, right? Which means it will continue with the code below it. So if the code manages to get to this point, then it return true, indicating that okay, it didn't return false, which means that all the row sums were equal to the first row sum. Okay, so I hope it makes sense. And that's it. So this function is either going to return true or return false. If it's either this or that. If it hits this point and returns false, that's it. The function stops. It doesn't run any code, but it just gets out of the function. We're done, and it returns false. If it manages to get past this loop, then it will return true. So it's either returning true or false. All right, so let's do the same thing. We're done. Let's do the same thing for has equal columns. So this is just to check to see if it has equal rows.